On August 12th, 2026, millions of people across Europe will stop what they're doing and look up, not because of a rocket launch, not because of a meteor shower, but because for a few unforgettable minutes, the sun will simply disappear. The sky will darken in the middle of the day. The temperature will begin to fall. Birds may suddenly fall silent. Streetlights could switch on automatically, and where the brilliant sun once shone, a black circle will hang in the sky, surrounded by a ghostly crown of white light. It's a sight so extraordinary that many people spend years planning their lives around it. Some travel thousands of kilometers, some cross oceans, some wait decades for another chance, not because it's rare for Earth, but because it's incredibly rare for one specific place. On August 12th, 2026, the moon's shadow will race across parts of Greenland, Iceland, northern Spain, and a small portion of Portugal before continuing into the Atlantic Ocean. For those standing inside that narrow path, day will briefly become night. For everyone else, the event will never look quite the same. But why? After all, the moon passes between Earth and the sun several times every year. So why doesn't a total solar eclipse happen every month? Why is the path of totality only about a few hundred kilometers wide? Why is the sun's outer atmosphere invisible almost every day of our lives, except during these precious few minutes? And why do scientists still study solar eclipses in an age where we have powerful space telescopes orbiting the sun? The answers reveal something remarkable. A total solar eclipse isn't simply an astronomical event. It's one of the most extraordinary coincidences in nature. A coincidence so precise that nowhere else we currently know in the solar system does it happen quite the same way. Today, we follow the moon's shadow across Earth. We'll discover the science behind one of nature's greatest spectacles, explore why the 2026 eclipse is attracting worldwide attention, and uncover why humanity has spent thousands of years chasing a few minutes of darkness. Because sometimes the best way to understand the sun is to watch it disappear. At first glance, a solar eclipse seems almost impossible. The sun is nearly 1.4 million kilometers across. The moon measures only about 3,474 kilometers in diameter. The sun is roughly 400 times larger than the moon. So how can something so much smaller completely cover something so enormous? The answer lies in one of the greatest coincidences in astronomy. The sun is also about 400 times farther away from Earth than the moon. That remarkable balance means both objects appear almost exactly the same size in our sky. If the moon were slightly smaller or slightly farther away, total solar eclipses would never happen. If it were slightly larger, the sun would disappear for much longer than it does today. Instead, our solar system exists in a narrow window where the geometry is almost perfectly aligned. It's a coincidence that has fascinated astronomers for centuries. Yet even that perfect alignment isn't enough. The moon doesn't orbit Earth in exactly the same plane that Earth orbits the sun. Its orbit is tilted by about 5 degrees. That tiny angle makes an enormous difference. Most months, when the moon passes between Earth and the sun, its shadow misses Earth entirely. The moon appears slightly above or slightly below the sun in the sky. No eclipse occurs. Only when the moon crosses the exact point where its orbit intersects Earth's orbital plane, and does so during a new moon, can a solar eclipse take place. This is why total solar eclipses are relatively uncommon. Even though the moon circles Earth every 27 days, nature demands extraordinary precision. When everything aligns perfectly, the moon begins casting a shadow toward Earth. But that shadow isn't uniform. It consists of 2 distinct regions. The larger outer shadow is called the penumbra. Observers inside the penumbra experience a partial solar eclipse. The moon blocks only part of the sun. The sky dims slightly. Shadows become sharper, but daylight remains. The smaller inner shadow is known as the umbra. This is where something extraordinary happens. Inside the umbra, the moon completely covers the sun's bright surface. Day suddenly transforms into twilight. That narrow shadow creates the path known as the path of totality. Only people standing within it experience a true total solar eclipse. Move just a few kilometers outside the path, and totality disappears. The difference between witnessing one of nature's greatest spectacles and missing it completely can be surprisingly small. Although Earth is enormous, the moon's umbral shadow is remarkably tiny by comparison. It usually measures only around 100 to 200 kilometers wide, though the exact width varies from one eclipse to another. As Earth rotates and the moon continues its orbit, that shadow races across the planet at speeds that can exceed 1,500 kilometers per hour. No human can outrun it. No aircraft can follow for long. The shadow simply sweeps across continents before vanishing into space once again. The total eclipse itself is brief. Most observers experience totality for only a few minutes. Some eclipses last barely over a minute. The longest possible total solar eclipse, under ideal conditions, can approach 7.5 minutes. The 2026 eclipse will offer shorter periods of totality, depending on where observers stand along the path. That brevity makes every second feel precious. Long before totality arrives, the world begins changing. The moon slowly covers more and more of the sun. At first, most people notice almost nothing. Even when half the sun has disappeared, daylight remains surprisingly bright. Our eyes automatically adjust. Only as the final portion of sunlight disappears do the changes become dramatic. The air begins cooling. The landscape takes on an unusual metallic tone. Shadows become strangely crisp. If sunlight filters through tree leaves, hundreds of tiny crescent suns appear on the ground. Nature quietly announces that something extraordinary is about to happen. Seconds before totality, another remarkable phenomenon appears. Along the edge of the moon, tiny points of brilliant sunlight suddenly shine through valleys and craters. These flashes are known as Bailey's beads. Named after astronomer Francis Bailey, they reveal that the moon's edge is far from smooth. Mountains and valleys briefly allow sunlight to pass through uneven gaps. For just a few seconds, the sun appears broken into brilliant beads of light. Then, only one dazzling point remains. That final brilliant point creates perhaps the most photographed moment of every eclipse, the diamond ring effect. A single intense burst of sunlight shines beside the dark silhouette of the moon, together with the faint solar corona surrounding it. The eclipse resembles a giant diamond mounted on a glowing ring. The effect lasts only seconds. Then it disappears, and suddenly, the sun is gone. For the first time, the solar corona becomes visible. This delicate halo of white light extends millions of kilometers into space. It's the outer atmosphere of the sun. Ironically, the corona reaches temperatures of over 1 million degrees Celsius, far hotter than the visible surface below it. Exactly why the corona becomes so incredibly hot remains one of solar physics' greatest unsolved mysteries. Spacecraft constantly observe the sun, yet during a total solar eclipse, the moon performs a task that no telescope can perfectly replicate. It blocks the sun's blinding photosphere with extraordinary precision. The result is one of the clearest natural views of the corona available from Earth. Totality also reveals something many people never expect. Planets and bright stars can suddenly appear. Venus often becomes visible, sometimes Jupiter. Brighter stars emerge against the darkened sky. For a few unforgettable minutes, the daytime sky resembles early evening. Animals respond as well. Birds may stop singing. Some return to their nests. Insects begin their nighttime routines. Flowers that normally close after sunset may briefly respond to the sudden darkness. The eclipse isn't only an astronomical event, it's an environmental event. For a few moments, the entire landscape reacts. Then, almost as quickly as it began, it's over. A brilliant point of sunlight reappears on the opposite side of the moon. The diamond ring returns. Daylight floods the landscape. Temperatures begin rising again. Within minutes, life continues as though nothing happened. Traffic resumes. Birds sing once more. People return to work. Yet everyone who witnessed totality shares the same realization. Photographs cannot truly capture it. Videos only tell part of the story. A total solar eclipse isn't simply something you watch. It's something you experience. Perhaps that's why people travel across the world to stand inside the moon's shadow. Not because the eclipse lasts for hours, not because it's the rarest event in astronomy, but because for a few extraordinary minutes, our ordinary view of the universe changes completely. The sun, the moon, and Earth align with astonishing precision. And for one brief moment, we're reminded that even the most familiar objects in our sky can still leave us speechless. Every total solar eclipse is unique. No two follow exactly the same path. No two cast their shadow across the same landscapes. And no two happen under exactly the same conditions. That's why eclipse chasers rarely stop after seeing just one. Every eclipse tells a different story. The one arriving on August 12th, 2026 is no exception. For astronomers, photographers, travelers, and millions of sky watchers, this is one of the most anticipated astronomical events of the decade. The moon's shadow will begin its journey high above the Arctic. From there, it will sweep across Greenland, race over Iceland, cross the Atlantic Ocean, and then reach northern Spain before continuing toward a small part of Portugal and disappearing beyond the horizon. Along that narrow corridor, daylight will briefly vanish. Outside it, millions more will witness only a partial eclipse. The difference is enormous. A partial eclipse is fascinating. A total eclipse is unforgettable. No photograph can fully explain why. Among all the places along the path, one country has attracted extraordinary attention. Spain. Months before the eclipse, hotels across northern Spain began receiving reservations from travelers around the world. Some eclipse enthusiasts booked accommodations years in advance. Astronomers, photographers, families, tour groups, people who had witnessed previous eclipses knew exactly what was coming, and they didn't want to miss it. Spain offers something unusually rare. In many locations, the total eclipse will occur late in the afternoon, with the sun hanging low above the western horizon. This creates an entirely different visual experience. Instead of seeing the moon high overhead, observers may witness totality against a glowing sunset sky, the dark silhouette of the moon, the delicate solar corona, and the warm colors of late afternoon combined into one of the most dramatic eclipse views possible. It's an opportunity that doesn't happen often. Further north, Iceland offers a completely different setting. Here, volcanic landscapes, glaciers, waterfalls, and rugged coastlines become the stage for totality. If weather conditions cooperate, the contrast could be extraordinary. A black sun suspended above one of Earth's most dramatic landscapes. For photographers, it's a dream. For scientists, it's another opportunity to observe the eclipse under different atmospheric conditions. For everyone else, it's simply unforgettable. Of course, one challenge follows every eclipse: the weather. Unlike planets or stars, clouds cannot be predicted months in advance. A perfectly planned trip can still end with an overcast sky. That's why experienced eclipse chasers don't simply look at the eclipse path. They study decades of weather records, average cloud cover, seasonal climate patterns, prevailing winds. Every percentage point matters, because during totality, there are no second chances. If clouds block the sun for those few minutes, the opportunity is gone. For this reason, many travelers remain flexible. Some rent cars instead of staying in one location. Others monitor satellite weather images until the very morning of the eclipse, hours before totality. Entire groups sometimes drive hundreds of kilometers searching for clear skies. It may sound extreme, until you waited years for an event lasting only a few minutes. Then every decision makes sense. Modern eclipse chasing has become an international community. People who had never met before often gather along the same viewing path. Complete strangers share telescopes, protective eclipse glasses, camera equipment, excitement. When totality finally arrives, everyone looks upward together. For those few minutes, language hardly matters. The experience speaks for itself. Professional astronomers also prepare long before eclipse day. Although satellites constantly monitor the sun, total solar eclipses still provide unique scientific opportunities. The moon naturally blocks the sun's intensely bright photosphere. That allows researchers to observe the faint corona with exceptional contrast from Earth. The corona isn't simply beautiful. It's one of the greatest mysteries in solar physics. The sun's visible surface reaches temperatures of about 5,500 degrees Celsius. Yet the corona surrounding it exceeds 1 million degrees. That seems backwards. Normally, moving farther away from a heat source should make temperatures lower. Instead, the opposite happens. Understanding why remains one of astronomy's biggest unanswered questions. During totality, scientists study the corona's intricate structure, magnetic loops, streamers stretching millions of kilometers into space, jets of superheated plasma. Every eclipse provides another opportunity to compare ground-based observations with data collected by spacecraft. Together, they help researchers better understand how the sun transfers energy through its outer atmosphere. Those processes influence something much larger: space weather. The sun constantly releases streams of charged particles into space. Most of the time, Earth's magnetic field protects us, but powerful solar eruptions can interfere with satellites, disrupt GPS signals, affect radio communications, even overload electrical power grids. Understanding the corona isn't merely an academic challenge. It's part of protecting the technology modern civilization depends upon every day. The 2026 eclipse also arrives during an especially active period of the sun's approximately 11-year solar cycle. In recent years, solar activity has increased dramatically. Sunspots have become more numerous, solar flares more frequent, coronal mass ejections more energetic. That raises a possibility that observers may witness especially dynamic structures within the corona. Every eclipse is different, and the sun itself is never exactly the same. For photographers, the eclipse presents another challenge. Capturing totality isn't as simple as pointing a camera toward the sky. Exposure changes dramatically within seconds. The corona is far fainter than the sun itself. Too much exposure, and delicate structures disappear. Too little, and the image becomes almost completely black. Experienced eclipse photographers spend months rehearsing camera settings before eclipse day. Some even automate every step, because during totality, there's no time to experiment. Every second counts. Yet many veteran eclipse chasers offer unexpected advice. Don't spend the entire eclipse behind a camera. Take a few photographs. Then look up, because the most unforgettable part of a total solar eclipse isn't something any camera fully captures. It's the sudden darkness, the changing air, the reactions of people around you, the silence, the feeling that something impossible is unfolding overhead. Those moments remain far longer in memory than any single image. For millions of people who won't stand inside the path of totality, the eclipse will still be worth watching. A partial eclipse reveals the moon gradually covering the sun, but it comes with one important rule. Never look directly at the partially eclipsed sun without proper certified solar viewing glasses or other safe solar filters. Unlike totality, when the sun is completely covered, even a small visible portion of the sun is bright enough to permanently damage human eyesight. Safe viewing isn't optional. It's essential when the shadow finally leaves Earth. The event will already belong to history. The moon will continue its orbit. The sun will continue shining. Life will return to normal. But for those who stood inside that narrow ribbon of darkness, August 12, 2026 will become a date they'll remember forever. Not because the sun disappeared, but because for a few extraordinary minutes, they stood inside the shadow of another world and witnessed one of nature's rarest performances. For thousands of years, a total solar eclipse inspired more than curiosity. It inspired fear. Long before astronomy became a science, people had no way of knowing why the sun suddenly disappeared in the middle of the day. To ancient civilizations, the event seemed impossible. The most reliable object in the sky had simply vanished, without warning, without explanation. Across the world, different cultures searched for answers. In ancient China, people believed a celestial dragon was swallowing the sun. Drums echoed across villages as people tried to frighten the dragon away. In parts of India, eclipses became woven into mythology and spiritual traditions. The Vikings imagined wolves chasing the sun across the sky. Other civilizations viewed eclipses as warnings from the gods. Despite the different stories, they all shared one thing in common. No one yet understood what was really happening. Everything changed when humanity learned to predict the heavens. As astronomy developed, eclipses slowly transformed from terrifying mysteries into mathematical certainty. The motions of Earth, the Moon, and the Sun could all be calculated. A phenomenon once seen as supernatural became one of the strongest demonstrations that the universe follows precise physical laws. In many ways, every successfully predicted eclipse strengthened humanity's confidence in science itself. The sky was no longer unpredictable. It was understandable. Yet total solar eclipses continued offering something that ordinary days could not. They allowed scientists to observe parts of the sun normally hidden by its overwhelming brightness. Even before the space age, eclipses became scientific expeditions. Researchers traveled across continents carrying delicate instruments, hoping for only a few minutes of clear skies. Those brief moments often produced discoveries impossible to make any other way. One eclipse, in particular, changed physics forever. On May 29, 1919, two scientific teams traveled to opposite sides of the Atlantic Ocean. One set up in Sobral, Brazil, the other on the island of Principe, off the west coast of Africa. Their goal wasn't simply to observe the eclipse. They wanted to test one of the boldest scientific ideas ever proposed. Just 4 years earlier, Albert Einstein had introduced his theory of general relativity. According to his equations, gravity wasn't simply a force pulling objects together. Instead, mass actually bends space and time. If Einstein was correct, light itself should bend as it passed near a massive object like the sun. Normally, the sun's brightness hides the background stars needed for such a measurement. But during a total solar eclipse, those stars briefly become visible. The moon created the perfect natural experiment. When the eclipse ended, astronomers compared photographs taken during totality with images of the same stars taken months later. The results matched Einstein's predictions remarkably well. The apparent positions of the stars had shifted exactly as general relativity suggested. It was one of the most famous scientific confirmations in history. Almost overnight, Einstein became an international figure, and a total solar eclipse became forever linked with one of humanity's greatest scientific breakthroughs. More than a century later, eclipses continue contributing to science. Today's telescopes in space observe the sun continuously, yet totality still offers something unique. The moon blocks the sun with extraordinary precision, allowing scientists to study faint structures extending far beyond the visible surface. These observations help improve models of solar magnetic fields, solar wind, and the mechanisms that drive explosive eruptions from our nearest star. Every eclipse adds another piece to a puzzle scientists are still assembling. But perhaps the most remarkable story isn't about science at all. It's about people. Ask someone who has experienced a total solar eclipse, not watched one online, not seen photographs, but stood beneath the moon's shadow. Many struggle to describe it. Professional astronomers, pilots, teachers, photographers, people from completely different backgrounds often use surprisingly similar words. Surreal, emotional, overwhelming, life-changing. That reaction has become so common that psychologists even have a name for it. Awe. It's a feeling that emerges when something is so vast, so unexpected, or so beautiful that it temporarily reshapes our understanding of the world. A total solar eclipse has a remarkable ability to produce exactly that response. Perhaps that's because an eclipse changes more than the sky. It changes our perspective. For a few minutes, millions of people stop checking their phones, stop talking, stop rushing. Everyone looks in exactly the same direction, up. The experience reminds us that despite our technology, our cities, our schedules, we still live on a planet moving through a much larger cosmic system. The sun, the moon, and Earth. 3 worlds separated by hundreds of thousands and millions of kilometers, yet perfectly aligned for just a few extraordinary minutes. The eclipse of August 12, 2026 will eventually end. The shadow will leave Spain. The Atlantic Ocean will brighten once again. The moon will continue its endless journey around Earth, and life will return to normal. But somewhere, someone witnessing their very first total eclipse may begin asking new questions. questions about astronomy, about physics, about the universe itself. Many scientists have traced their passion for space back to a single unforgettable moment beneath an eclipse. Inspiration often begins with wonder. There is another reason this event matters. The moon is slowly moving away from Earth. Every year, it drifts outward by about 3.8 centimeters. The change is tiny, impossible to notice within a human lifetime, but over millions of years, it becomes significant. As the moon moves farther away, it appears slightly smaller in our sky. One distant day, it will no longer completely cover the sun. Future eclipses will become annular rather than total. The spectacular solar corona that amazes us today will no longer be revealed in the same way. Total solar eclipses are not a permanent feature of Earth. They belong to a particular chapter in our planet's history, and we happen to be living within it. That realization changes everything. A total solar eclipse isn't simply a beautiful alignment. It's a reminder that even the grandest events in nature can be temporary. We often think of the universe as unchanging, but nothing remains exactly the same forever. Planets evolve, stars age, galaxies collide. Even the relationship between Earth and its moon slowly changes with time. The sky our distant descendants will inherit won't be identical to the one we see today. Perhaps that's why people continue chasing eclipses across deserts, mountains, oceans, and continents. Not because they're trying to escape the sunlight, but because they're trying to witness one of the rarest combinations of beauty, science, and coincidence that nature has ever created. For a few minutes, the brightest object in our sky disappears. The invisible becomes visible. The ordinary becomes extraordinary. And the universe reminds us that even familiar things can still inspire wonder. On August 12, 2026, millions of people will look toward the sky, expecting to see the sun. Instead, they'll witness something far rarer, a perfect alignment, a fleeting shadow, and a reminder that some of the universe's greatest spectacles last only a few minutes. The sun will return, the day will continue. But for those who stand beneath the moon's shadow, those few minutes will be remembered for a lifetime.